A KQED HD production.
On a windswept tarmac at the former Naval Air Station in Alameda, California, an inventive group of scientists and engineers is testing the concept of a new clean energy technology. With a changing climate and mounting energy challenges, the race is on to develop viable sources of alternative energy.
There are not very many options for providing low-carbon power at the scale of civilization. To solve this problem, we need a real revolution in our system of energy development.
Now, some people are hoping a solution can be pulled out of the sky. Ken Caldera is a climate scientist at the Carnegie Institution of Global Ecology at Stanford University.
We need huge amounts of power. And the things that can provide huge amounts of power include fossil fuels like coal, oil, and gas, nuclear power, solar power, and wind. Wind is relatively affordable, but there's controversy about whether wind on the surface of the planet can provide enough energy to really power civilization.
With the right conditions, modern wind turbines are able to harness power quite well. The force of the wind spins a turbine or propeller, which turns a drivetrain, converting kinetic energy into mechanical power. That energy is then sent to generators, which convert and send it out as electricity. But as simple as this technology seems, wind energy still only accounts for 2.8% of our nation's electricity.
The problem with wind is that wind is intermittent, that it blows sometimes and not other times. The basic forces that drive the winds are differential heating, right? So if one place is hotter than another place, that tends to generate winds. And because of the weird physics on a rotating Earth, around the mid-latitudes where you have the transition from the tropical air to the Arctic air is where you get these powerful jet streams. As you go down in the atmosphere from the jet streams, the winds get weaker and weaker and more variable.
Winds are stronger and more consistent the higher up you go. So in order to collect the most energy, wind turbines are mounted on tall towers, up to 100 feet above the ground. Now, a number of private companies, some supported by the U.S. Department of Energy, are working to figure out how to capture power from even higher altitudes.
Launch in 3, 1, 2, 3, launch.
One company, Makani Power, is taking inspiration from an unlikely source.
The wing that we fly around is actually, by definition, a kite. So it's a tethered airfoil. Makani's technology is very similar to a conventional wind turbine. And in fact, the physics and the principles behind it are exactly the same. So if you look at a conventional turbine, the traditional tower with 3 blades coming off of it, and you look at that blade, the tip of the wind turbine blade is the most effective part of the blade. What we do is we take only that tip. So if you imagine a tip flying around in circles on a wind turbine, and then imagine erasing away the rest of the wind turbine except for one tip of one blade. And that looks just like what our wing looks like, except for we take that wing and then we attach it to the ground with a flexible tether. And that means that we're able to fly higher than conventional wind turbines. It also means that we're able to sweep through circles which are much larger than the circles of a conventional turbine. Higher up means the air is more consistently at a higher speed, so there's more energy in the air. We can capture more energy with less wind. And that just means that you're able to generate more energy more of the time.
Theoretically, tethered wings could fly thousands of feet high, be more than 100 feet long, and consistently generate more than twice as much electricity as conventional wind turbines. But for now, Makani engineers are test flying smaller prototypes at average altitudes of around 500 feet.
Makani is currently developing Wing 7. Wing 7 is the culmination of all of our different prototypes, and moreover, it is also the first scale mock-up of what we expect our megawatt class device to look like. From Wing 7, we expect to build several 500 kilowatt prototypes. It will be the first large-scale device that is also capable of flying for long periods of time. Following that, we expect to build a megawatt class device, and that'll be our first product. And we expect that product to be fully tested, to have been flown for more than a year, and be ready for production at the end of 2015.
Okay, restarting data acquisition and starting motors now. It's spinning up.
This is the Wing 7 prototype at Makani Power. It's a small-scale prototype of an airborne wind turbine. The way it works is the wing here flies just like the tip of a blade of a wind turbine, and it propels these generators around in a circle and moves them through the air very quickly so that these smaller propellers can generate power, which is then shipped back to the ground over the tether. This is the avionics, and what it does is it looks at all the sensor data coming in, and it decides what the wing should do. We take all this stuff and we put it together and use some very smart algorithms to decide what's the best thing we can do to be safe, and number two, optimize power output. The future of this, I see a lot of these things offshore, generating power out of sight so we don't have to worry about them. So that's the goal.
It may seem pie in the sky, but companies like Google have backed up the potential of this technology with investment dollars. And many energy experts are betting some sort of airborne wind power will soon get off the ground.
People say airborne wind energy, but it's really not one thing. There's a whole bunch of things that are in that airborne wind energy basket. There are kite-based ideas. Other people have these ideas of having balloons, and either the balloon itself is spinning or there's a wind turbine on the balloon, and so there's balloon-mounted systems. There are other designs that look like gyrocopters flying, where it's kind of more like a helicopter-looking design. And so there are many different designs, and it's not clear which will win out.
The holy grail of airborne wind energy development would be to somehow find a way to capture the elusive power of the high-altitude jet stream.
The jet stream is a river of extremely powerful winds that are up around 30,000 feet high in the atmosphere, and they circle the globe in a kind of meandering pattern. And the power from the jet stream is really driven by the temperature contrast between the warm air around the equator and the cold air at the poles. And the amount of power in the jet stream is really huge. The winds are typically over 100 miles an hour, so it's hurricane force winds. We've done computer simulations of airborne wind energy where wind turbines were put up into the jet stream. And we find that there's more than 100 times the power necessary to power civilization in these high-altitude winds.
Okay, launch.
Building a craft that could fly that high, withstand that much force, and still transfer energy back to the ground is a long way off. And there are other major hurdles just to get this technology up and running.
I'm just a little skeptical that you can actually make something that's cheap and that you can fly for a long time. You want something that has the reliability of an airplane, but the cost of what a regular wind turbine costs. They're going to have to bring them up and down for maintenance. It's got moving parts. Anytime you have moving parts, something's going to wear out and go wrong. Nobody's going to want to live under that. So there's no shortage of challenges.
Other issues include the effects on wildlife, how to fly at higher altitudes without interfering with commercial aircraft, and how to keep hundreds or even thousands of airborne wind turbines aloft at the same time.
We have a hard road ahead of us. This is a challenging project. It's also a fascinating project in terms of engineering. The intersection between controls, aerodynamics, power generation, avionics, all of those components rolled into one very interesting device is really unique.
Experts believe with advances in materials and technology, airborne wind energy is technically feasible. And the flying turbines being built today may help launch a new energy revolution.
I'm sure when the Wright brothers said that they wanted to make a flying machine, people thought they were crazy until they did it and they showed it can work. To me, the wind turbines in the jet stream are kind of like the supersonic Concorde flying from one continent to another. And even if the Wright brothers had that in their mind when they were at Kitty Hawk, they didn't start off building an intercontinental supersonic transport jet. So I think the key is to get started doing something.